we spent some time talking about linear, not linear, looking at equations, looking at tables. What I'd like to talk to you today about is arithmetic sequences. An arithmetic sequence, that's one where we're adding something each time that has a constant rate of change. Okay? So that's linear. Do you all understand that? An arithmetic sequence is a linear sequence. Kind of has the same idea, okay? I can show you one right here. Okay? And out here, I'm going to put a sub n. We're going to talk about what this means for a minute. So, each of these is called the term of the sequence. Sometimes we call them nodes of the sequence. But it's pretty straightforward. Can you guys all see the first term? Okay. And this first term right here is a 5. Can you all pick out the fourth term? Easy enough, right? Okay, there's our fourth term. Can you all see the nth term? Okay, so right here we have the nth term. And what that means is whatever it is. It could be the 20th term, it could be the 100th term, it can be whatever, okay? So as we look at a sequence, there's some different things that we're always concerned about. I think the biggest one is, what's the next one? So if I write a sequence like this, what's the next one? Yeah, it's 30. And the next one, 35. And how do you get the next one? You add 5. Okay, so that's great. We know what we can figure out what the next term is, and we know what we have to do each time. And that adding 5 thing, does that have anything to do with what we've talked about with linear equations before? Yeah, it's the slope. It's the constant rate of change, isn't it? Okay, so our slope, okay, that's, if you know what the slope is, well, that's how you get the next one, isn't it? Okay, we just go from there. Now, I don't think we have a whole equation, though, and then things get a little bit more tricky when I say, well, what's the 20th term? What's the 100th term? Did that make things get a little tougher? It does, doesn't it? Okay. So let me just tell you, in this equation, which by the way looks like this, surprise, right? It's a linear equation. It's an arithmetic sequence. In this equation, when I put a 1 in, where do I put a 1 in? When I put a 1 in for x, what comes out? 5. When I put a 2 in for x, what comes out? And when I put a 4 in for x, yeah, okay. And when I put an n, when I put the nth term, like the 20th or whatever it is, I get this out. Okay. So we have part of this equation already, don't we? We know the y equals, do we already know m? Oh my gosh. Okay. We already know that has to be an x, don't we? There's only one question. The initial amount, the beginning term. And this is so tricky. This is the part that kicks your butt, because it's not that one. Is it? No, it's 0. Okay? We don't put the first, the y-intercept is not the first term. It's not what we get when we put 1 in. It's what we put when we put 0 in. It's the 0 term. So the 0th term, in this case, is 0. And with this equation now, we can say, well, this is the fifth term. We can find the next one. We can find the sixth term, no problem. Can we find the nth term? In other words, can I find any term I want? Can I find the 20th term? Yeah? What do I do? Yeah, we put 20 right there. 5 times 20 is 100. That's right. So if we want the 20th term, we can do that. Okay? We just have to remember that the y-intercept is not term 1. It's term 0. Okay? It's what we get when we put 0 in. And if you can remember that, you can come up with an equation for this. By the way, what do you think would happen if I were to graph these points? 1, 5, 2, 10, 3, 15, 4, 20. What would it look like? Yeah, they'd line up. Those points would line up, wouldn't they? Okay? It's an arithmetic sequence. That's going to be simple to look at. Okay. So does this look like an arithmetic sequence to you guys? I can't hear you nod your heads. Okay. Can you see a common difference? Okay. Yeah, now that's something we got to make sure. We don't want to just say 0.2, do we? Isn't the common difference negative 0.2? Right? Could you find the next term in the sequence? So this is 1, 2, 3, 4. The fifth term in the sequence, 0.2. And then 0.0. And then negative, isn't it 0.8? Negative 0.8? Or is it point? Are you sure it's 0.2? Isn't it 0.8? 0.2. So when we're at 0, so the next one down is negative 0.2, and then negative. Okay, so we're not at 1 going down from there. So how about the next one? Okay, all right, you got it. Okay, so we know that it's an arithmetic sequence. We know it's linear. We know the constant rate of change, or the common, we call it the common difference. Common difference. Constant rate of change. Slope. There's a lot of names for it. Slope makes no sense whatsoever except for when you're graphing it. You know what I'm talking about? Okay, in a real problem like slope, what are we even talking about here? Constant rate of change or a common difference? What about the 0 term? So is that the y-intercept then? 1.2? So that's our y-intercept, or our initial amount, or what we get when we put 0 in the equation. Do you understand that? Yeah. That's the number we get when we put 0 in the equation. So our equation is y equals negative 0.2x plus 1.2. Now let's check, does it work? If we put 0 in for x, do we get 1.2 out? Yeah. If we put 1 in for x, does this work? Yeah. It has to be negative. Oh, yeah. It does, because we end up with negative 0.2 plus 1.2, which is 1, right? Mm-hmm. Okay. If we put 2 in, does it work? Yeah. Okay. So, do you understand? It's important to know, how do we get the next one? But it's also really important to be able to say, well, what's the nth term? Do you understand what I mean by that? The nth term, the 20th term. What's the 100th term in this series? Okay? And we really can't figure that out without being able to write that equation, can we? Is it making sense? Yeah? Cordell, you good? Yeah. Okay. So there's some formulas. Let me show you something here. Here's the first term of a series, 14. Here's the common difference, also known as the, I'm going to say slope so it fits in our equation. So there's a formula. A sub n equals a sub 1 plus the quantity n subtract 1 times d. Oof. Okay. So what this formula is for is to find some term in the series. If we know the common difference and we know the first term, we can use this formula to find any term in the series that we might want. You might want to write this down, although we might make it superfluous here in a second. We kind of already have. So let's say I want to find the 10th term in this series. That would be a sub 10. Y'all okay with this? Yeah. Looking for the 10th term in the series. So I write down equals a sub 1. Do we know what a sub 1 is? 14. Okay. Plus, and then in parentheses, n subtract 1. Now n, in this case, what are we looking for? A sub 10. So what is n?
10.
Yeah, it's a 10. 10 subtract 1. And then what do you think that d stands for? The slope, the common difference. Isn't that stupid that we're using a different variable for the slope when it's the same thing? It's the common difference. So I need to put in that parentheses. So a sub 10 equals 14 plus 9 times negative 3. So a sub 10 is 14 subtract 27. I'm not going to put plus negative 27. Are you okay with that? Okay. So a sub 10 is negative 13. Now that's great. There's a formula. We can find the nth term of any series. Okay? But can you guys tell me the 0th term in this series? What's the 0 term?
14.
No, wait, the first term was 14. What's the 0 term?
4. Oh, 5.
Hold on. Slow your jets here for a minute. We got a constant rate of change. We have a slope, right? Common difference. We know the first term. Can we go back to the 0 term? What is it?
17.
It's not 17. What?
11.
It's 11. Where the crap did 11 come from?
14.
I was hearing both of those from you. If it's 11 and we go negative 3 from there, are we to 14? If we're at 17 and we go negative 3 from there, are we at 14? Okay. So there's our 0 term. Did I say it's not 17 for a second? Yeah. No, I'm sorry. I was hearing both answers and I wanted to make sure we were on the same page there. Okay, anyway, we know a sub 0. We know a sub 0 is 17. We know the slope's -3. Can we write an equation? Y equals -3x plus 17. That's the equation that describes this series, right? So if I want to find the 10th one in the series, can we just put 10 right there for x?
Yeah.
Let's try it. -3 times 10 plus 17. Did it work? Yeah, it did work, didn't it? Okay. Might have been better if we wrote it f of x equals -3x plus 10, because then we could say f of 10 equals -3 times 10 plus 17. Okay, so let me just think about this for a minute. This is great. We can find the nth term of any series. All we need is the first term and the common difference. But if you have the first term and the common difference, can you find the 0 term and write the equation and then find any term you want? Yeah. Okay. So, you know, this formula is great, but I mean, if you're going to go to all that work, shouldn't we just figure this thing out? Let's try a different series here for a minute. Now the way I've written it, where there's no dot 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 before this, that means that is the first term. Okay, so the first thing I think we should start looking about is, what is the slope or the common difference here? Or I guess maybe the first thing we should look at is there a common difference? Is this thing arithmetic? What's happening every time? Subtract 1. Okay, so yeah, we have a common difference here, a slope. Can you guys tell me about the 0 term? What is it? There you go. It's 2. Can we write the equation? Here, I'm going to write it this way. F of x. What does f of x equal? Plus 2. So, can you all tell me the next term in this series? -3. And the next one? -4. Can you tell me the nth term in this series? In other words, can you tell me the 100th term? Can we do that? What do you think? This making sense? Okay. It is a little confusing where you have the first term and then we're really concerned with that. What do we get when we put 0 in the equation? Okay, that initial amount. Okay, so you can finish up that assignment first, and then you can start working on this one. As soon as you're done with that assignment, the cumulative review, would you put it in the box, please?
Are we going to give a test?
No, because we've still got, Carson's still doing his, because he was absent.